Hello, this is our team's presentation of financial risk management. Our team is Abigail Melendez, Natalia Robles, Luis Donaldo Ballinas, David Alejandro Calvillo, and Ana Lucia Ruiz. The date is January 31st, 2022. We estimated three models with the testing set in order to find the good and bad model as the assignment requested. Our first model was loan status for our dependent variable and interest rate, annual income, and the grade were the independent variables. We obtained an AIC of 13,047. Then the second model was loan status for our dependent variable as well, with annual income, employment length, region, sex, and interest rate were the independent variables. This model obtained an AIC of 10,798. The third model had a loan status as a dependent variable with interest rate, grade, annual income, sex, employment length, region, and home ownership as their independent variables with an AIC of 10,760. This model had 7 independent variables. Now, in order to evaluate the good and the bad model, we chose the first because the AIC criteria was 13,047 and the third model because the AIC value was 10,760. We proceeded to evaluate them with the test, and then we established the cutoff value of 80% that helped us to evaluate them.
Another criteria that helped us to evaluate our two models was the bad rate and the acceptance rate. The bad rate means the proportion of accepted loans that are actually in default. So the bad rate of the first model was 8.83% and 5.76% for the third model. So we know that the best model so far is the third because our intention is to have the lowest rate possible because we don't want to accept default. Now, we did a table about the bad rate and the acceptance rate. The third model is superior because at any acceptance rate, we obtain a lower bad rate. Also, the graphics on the third model are similar to the full model in the tutorial. The tendency is smoother in the third model than in the first. For example, if we have an acceptance rate of 40% in the first model, we have a bad rate of 5.31 and in the third model of 1.52%. Now, if we have had an acceptance rate of 70%, the first model will have 8.2% and the third 4.34%. If we did the worst case scenario and we had an acceptance rate of 0%, we will have a bad rate of 0%. And if we accept everyone, we will have a bad rate of 100%, which is bad. Another thing that we would like to point out is that if in the third model we had an acceptance rate of 20%, the bad rate will be 0.361%. However, if we did the same acceptance rate for the first model, we will have a bad rate of 3.55%.
So we conclude that it is important to first estimate the models that we're going to be working with because it will help us to choose the best model to predict, in this case, the probability of default. Then we need to have at least a second criteria to evaluate the model. For us, the best criteria was to establish a cutoff value and then check the acceptance rate and the bad rate. It was necessary to compare these two models in order to see the difference of a good model and a bad model. Last, we believe that if a model is more complete, the probability of them to predict correctly is very high. So we saw in model 1 that only had 3 independent variables to the third model that had 7 independent variables. Thanks for your attention.